Thank you to everyone for taking time to attend today. I appreciate your interest, and hopefully we'll have a chance to discuss some of the themes that I bring up here. So the focus of what I'm going to be talking about this evening for me, I'm in Western Australia, so it's 6 o'clock tonight for me. It's AI and ML, but it's looking at how those techniques and those methodologies are being used for supporting low carbon energy type projects. I'd like to acknowledge that this is a joint effort. So I've got material here from one of my colleagues at Katalyst in Calgary, Stephen Gallant. And I've also got some material provided by Pratik Kumar, who is with ONGC in India. So the idea was to get some different ideas about what people are doing with AI and ML in the context of the energy transition. So we're all hearing about new energy and sustainable energy and the energy transition. And sitting here in Australia, maybe even more so than other places. So especially around carbon capture and storage, which is going to be one of the focuses for this presentation. Just a little quote here, just to let you know how timely and topical this is. This is our Australian Resources Minister, the Honourable Madeleine King, and just a few days ago she was on public media talking about how carbon capture and storage is the only way that Australia, in this case, is going to maintain a sovereign oil and gas industry. And this is obviously a big talking point, both politically and economically, for a resource-driven economy like Australia's. So what is this new and sustainable energy about? Well, low carbon energy is not new. So if we look at the three areas where we're seeing most activity here in Australia, hydrogen as an energy source, geothermal, and carbon capture and storage, these are not new things that are happening, right? Hydrogen was first demonstrated to be flammable and a possible energy source more than 300 years ago. Geothermal has been around for 10,000 years. The indigenous tribes of North America were using geothermal hot springs as an energy source to heat their huts in the winter more than 10,000 years ago. And carbon has been captured in the geologic record for most of Earth's history. So we're not doing anything new in terms of using these technologies. What we are doing is we're finding new ways to use technology. So rather than think of them as old-fashioned ways of utilizing these technologies and these techniques, we're finding new ways of using technology and especially digital data to support our use of those types of energy. So, and when I say finding new ways of using data, I'm not talking about necessarily using new data. So this is going to be one of the interesting things that we cover here. In the search for new energy, whether that's exploring for natural hydrogen or looking for pore space in which to inject CO2, we're very often finding ourselves reusing legacy data sets. So this is a picture of the Railroad Commission in Texas, which is the government agency in the state of Texas that regulates and monitors and takes possession of oil and gas data records. This is an actual picture of their records room. So you can imagine somebody looking at a basin in Texas and thinking, I wonder what the pore space is like there for a carbon storage project. I'm going to go look at some legacy well data. And they get with the commission and the commission says, sure, here's a box of records, right? This is a data management nightmare. So if what I'm really looking for is one of these well logs, the first thing I want to know when I open a box is what in there is a well log, what is something else like a bar chart that looks like a well log, and what's somebody's lunch menu that just got stored there with the rest of the data. So, and a person opening a PDF file or opening a physical copy of a record is very good at determining that. What we're finding is that well-trained machine learning algorithms are getting to be as good, if not better, at image classification. So find me a particular kind of data that looks a certain way. As a data management service company, we see an opportunity here. because we know that our clients are processing mountains of unstructured data from tens of decades of legacy exploration. Getting that data into a digital format, a standardized digital format, is way too resource intensive for them to take on. And even our own internal systems for working with the data that our clients send us are being overwhelmed by the volume of data that they're being asked to work with. So we turn to our machine learning and AI engineers to help us solve that problem. And I'm going to share with you a few of the things that we're doing. So in an operations workflow as a data management company, if we get a box of data to be archived and cataloged and indexed and then displayed for a client, one of the first things we need to do is understand what's in that data. So our machine learning service and the user interface around it is designed to help our indexers, who are people, humans, automatically and accurately pick and extract values from standard data types that we work with every day. So sounds like an easy task, but it turns out it takes a little bit of tuning of the machine learning algorithms. What we're looking to do is identify those data types. So for instance, a well log header and maybe a seismic EPSODIC header, and then extract from that the high scoring metadata candidates that we think we're going to need to index that data and put it into a data store where somebody can find and access it. So what we're doing is we're using those verified choices to then fully populate an inventory item in a database, whether that's an on-prem relational database or a cloud-based object storage. And this is what we do every day, right? We're indexing, standardizing, and cataloging data. And if we can get a machine to help us do that, so much the better. We can process more data, we can charge our clients more, and we can return value to them sooner and quicker so that they're working with digitized data to support their business decisions. So how do we do that? No surprise, pre-trained convolutional neural networks. There's a particular one that we're using in this case study, and the idea is to have a robust training data set. So in our case, because we work with large volumes of data, we've got more than 100 petabytes of data under management across our global systems. We were able to pick a group of 3 million image pages and use that as a training set for this convolutional network model. Now, we were able to do this because the work was partially supported by a Canadian program that's an industrial research assistance program. We selected well log raster images because we know that's high value for people that are looking for, especially in new energy sources, and we'll get to that in a minute. The reason well logs are of particular interest for new energy, low carbon projects, and especially in Australia, is that in Australia, all well completion reports are submitted to government regulators. They become open file, public domain data after 2 to 5 years, depending on the state or the Commonwealth level. The well logs that people are looking for that might give them a clue as to the existence of natural hydrogen or the ability of a deep saline reservoir to be a storage location for carbon dioxide. Those logs are very often embedded as a raster image somewhere in a zipped up, scanned PDF file with multiple zip levels before you get to the raster image. Nobody's going to spend the time required manually first scanning and then zipping up and unzipping all of those files. So we're relying on machine learning to help us make that process more efficient. And what our clients are looking for, and what we're assisting them with machine learning, is looking for references to bypassed new energy indicators. And we'll give you a couple of interesting examples of how that works. So kind of a standard machine learning and AI workflow. We have an extensive warehouse, not only of these training data sets, but of fully indexed and quality controlled metadata lists. So we're able to populate the label value pairs pretty easily. You'll see some of the kind of requirements for running this through various variations, waiting for the machine learning to kind of converge to an acceptable level of positive identifications. And some of the results that we're churning out for our indexers still in an internal application is this user interface that allows them to then use machine learning as basically a coworker and a colleague, as we heard last night in some of the presentations, to help them with their indexing tasks. So what kind of things are they looking for? Well, in Australia, there's a big push to find natural hydrogen, so sometimes called white hydrogen, basically free hydrogen in the geologic record. In a lot of cases, that hydrogen was detected 40 or 50 years ago in the search for hydrocarbons, but nobody was interested in hydrogen at the time. So at best, they identified it as an inert gas, or at the worst, there's something like this, a 1930s site report from a well drilled for hydrocarbons. Somebody said, oh, look, we got some gas coming up through the baler. I threw a match at it and it exploded. They never said it was hydrogen, but if we understand a little bit about chemistry, we can draw some inferences there. This particular report was filed under the wrong well name in a government open file database, right? Which means nobody would find it doing a metadata search or a keyword search for something that mentioned hydrogen. And this led the director of our energy resources in the state where this occurred to say, look, it's possible that because of this lack of standardized index data, some hydrogen occurrences have been missed by explorers, and that's a missed opportunity for revenue for the state. So there's a lot of interest in applying this kind of information. Here's another example of using fluid inclusion data, maybe collected for an entirely different reason, right? Looking for total organic content, to give an indication that there may be hydrogen trapped and sealed in a particular part of the reservoir. In this case, we're looking for an LAS style log file, again presented as a raster image, embedded 4 levels deep in a zip file with a file name that tells you absolutely nothing about the fact that it's fluid inclusion data, and all the data managers in the audience will love this, a unique well identifier of a string of 9s, right, which is anything but unique. So you think about the process that somebody would have to go to understand that this log is telling them something about free hydrogen in the wellbore, and we've got to accelerate that process. So that's where we're finding value in using machine learning. My co-author and colleague in India at ONGC also has been working with extracting, for instance, permeability and porosity values from existing well logs using model ensembles and using that to classify and predict lithology. And that can become input to geocellular models that tell us what the storage capacity might be in an existing facies that has been drilled through in a search for hydrocarbons. So another reusability story around that kind of digital data once the machine learning has been used to help process and deliver that data. Here in Australia, we're also looking at extracting data from wellbore schematics to understand what is still downhole or left on the seafloor in an existing facility. And the reason this is important is because in some cases, companies are looking at the cost of decommissioning a well site versus the cost of turning it into, say, a CO2 injection site. And in order to make that decision, you have to understand all of this information about the equipment that's in the hole, how long it's been there, what its true specifications are. And again, that information is very often buried in a scanned, at best, image file and requires OCR and natural language processing to pull it out. So some of the reasons that we feel we've been successful using this in a data management workflow is that, well, first of all, we've got access to a lot of industry standard taxonomies, categories, vocabularies, reference lists. We get those from PPDM, we get those from OSDU. We work with consortiums that work with, for instance, geochemistry data. We're doing some work with the Blockchain for Energy group around entitlements and obligations. So we've got a lot of industry standard nomenclature that we can use to create that training data set with properly curated labels and value pairs. And we've also got an ecosystem, because we manage data and deliver it to our end users. We've got an ecosystem that supports a full chain of custody of that data as it goes through the process from a hard copy report all the way to delivered and indexed data. The innovative parts of this are really that what we've done is we've created a tool that helps us quickly label and verify huge volumes of data. Our data warehouse in Houston is processing something like 10,000 data items a month for our combined set of global clients. And we're able to business test and verify the fact that, yes, we're correctly indexing data using our friend machine learning as a colleague and a coworker. Some of the caveats to think about, some of the things we've learned in doing this are that even the original raw data needs some kind of pre-processing for training. So if you're scanning a report and then OCRing it and using natural language processing, you're basically doubling or tripling the volume size from the original scanned image. So you have to provision for that. And you want to apply some kind of deduplication in that early part of the process, or you wind up expending your machine learning resources working the same file potentially multiple times.
Jess, just to say, you've got 5 minutes left. Thank you.
Yep, perfect. Thank you. Appreciate that. So some of the next steps that we're thinking about in expanding the application of this, especially for new energy projects. You can see some of them on the screen here. Obviously, we want to improve that those OCR processes, so we can do things like pick up handwritten notes and scribbled in the margins of a mud log, maybe. We're always adding additional taxonomy categories so that we can work with different data types. We're expanding into the mining industry because we're finding that borehole assay data is now finding a use in describing the hydrothermal zones that contribute to natural hydrogen production. And we're working our way into image classification and analysis for things like core photos and schematics. So some really interesting work going on there, and obviously continuous application to real world work and value. So the idea here is that using machine learning as a coworker, as a colleague, not as a replacement for human indicators or indexers, but as a enhancer. We think we can essentially double the efficiency of our human indexers, get them up to working something like 200 SegWi files successfully indexed and quality checked in a day, or 500 wells, which is about a 2x efficiency improvement from where we are today. And we view this as not as artificial intelligence, but as intelligence augmentation. That is, we hire really intelligent people. We're giving them the ability to apply that intelligence where they're best at doing it as humans, by automating repetitive tasks, helping them to analyze their decisions about what is the correct metadata, and basically unlocking that workforce's subject matter expertise where ChatGPT wouldn't know what they're talking about. The last night while we were playing around with ChatGPT, I asked it what fields in a SegWi file would be most likely to be mispopulated, and I got some really interesting answers. So that's something where humans still help us out. So, and all of this, of course, leading to the idea that a task that might have been too resource intensive a couple of years ago can now be taken on and add value to an operator looking for low energy projects. So that's a quick overview of some of the things we're doing. I look forward to kicking off discussions in the breakout session after our next presentation. So thanks for your time and attention. I appreciate it.
Fantastic, Jess. Very interesting presentation, and you mentioned this AI as a co-worker, not a replacement, and this has been a common thread that we've found throughout this conference so far. This idea of augmentation. I don't know if anyone on the call, maybe yourself, Jess, has ever been a gamer. I'm not a massive gamer, but there's a PlayStation game called Deus Ex Machina, and in that humans have augmented capabilities, and it seems to me that the world is kind of close quite quickly with robotics and AI moving towards that kind of that kind of world. So we do have some questions in the Q&A. They are at the minute all from me. Clearly, I was very curious, Jess, about your presentation. So I'll also prioritize other people's questions as they come in. But you mentioned about OCR. You know, I work in compliance. I work a lot with legacy data, and it strikes me that OCR is one of the key challenges, right? And do you think it's currently good enough to enable the AI machine learning that we need it to do on our legacy data sets?
So OCR has become a kind of a commoditized process and workflow. There's different levels, obviously. You know, you spend the resources you need to get the OCR result that you want. It's highly dependent on things like you know, typefaces, original quality of the image if it's a scanned image from a hard copy, paper copy. Interesting that we're getting requests now to scan well logs that have well headers in Cyrillic or Arabic. So you've got other language sets, other alphabet sets. You've got information, you know, in different orientations along a well log, horizontal and vertical. You've got, as I said, handwritten elements in the margin. Yeah, so I think the potential is there with the right training set. Yes, you can get there. I mean, I got switched on OCR when I realized that an OCR engine could actually be trained to correctly read my handwriting, right? That was my bar. When that happened, I said, okay, it's magic, right? Because I can't read my own handwriting. So, yeah. With the right level of processing and resource expended on it, yes, I think it's there.
It's really great to hear, because it has been a concern of mine. And that was another thing that came up in the conference. Sorry, I can't remember who was talking about it now. Was you know, about these large language models. Maybe it was Henri Blondel, I'm not sure. Talking about sort of data managers as being the kind of you know, creating the prompts and training these models, and perhaps training these OCR models, as you say, is something that we have to do.
Exactly.
And it might be a common task. Maybe it's something that we do on an old geophysicist's handwriting from one day or not. That's very interesting. Another question, again, from myself. I hope you don't mind me asking all the questions.
That's fine.
You mentioned the CCUS business, and you know, it's something that the UK are obviously exploring a lot. Reuse of legacy architecture offshore, but also onshore. We're seeing a massive uptake, by the way, in the request for legacy data that, quite frankly, I think even 10 years ago, very few people really cared about it, especially old seismic, old site surveys, even though they're out of date pretty quick. The reason, the question is, the CCUS business model has much smaller margins, right, than the traditional sort of oil and gas business. Do you see that AI machine learning technologies will sort of enable or be one of the key enablers of that business model going forward? And how else can you see data management helping to, you know, help that business go forward with such lower margins?
Yeah. So it's an interesting question, and a good one. And here in Australia, we've actually got some case studies that demonstrate that for the two basic targets for carbon sequestration, obviously the easiest one to evaluate is a depleted oil field, right? Because you've already got a lot of data, you've got multiple wells, you've got a production history, you've got information about how that reservoir behaves under pressure change. The real challenge is if you're looking at a deep saline reservoir, which has potentially, you know, a 10-fold larger pore space to inject into, but a sparse data set that tells you what that permeability and porosity really looks like, because people don't drill deep wells into saline reservoirs until now, right? So the hunt for that key piece of data that tells you something about the economics of using a deep saline reservoir is really a key place where machine learning can point you toward you might want to look at this well because it's got some interesting text in the bottom part of the well. After they went through the hydrocarbon reservoir, they TD'd in deep saline and somebody went, gee, that's a lot of porosity, and then plugged and abandoned it. But that's the kind of information that can be valuable in today's business opportunity.
Because
yeah,
obviously what we've been, training our whole industry to do, both human and whatever kind of algorithm that you want to talk about, it's been looking for particular hydrocarbons. If you're looking for hydrocarbons, maybe we need to shift. Well, we obviously do need to shift because you're looking for something else. And maybe AI can help us do that because we're training it to look for things that we would maybe have missed or we haven't been looking for per se. And of course, getting the data digital and readable is a big part of that. Patty's got a question here. Could you please elaborate on the challenges or surprises you encountered at the beginning of these CCUS projects? Were there any unexpected positive situations that arose during the project?
Yes. So one of the early challenges was around recognizing that even in a standardized data set, people still use different language to talk about different metadata attributes. So, what is a well header in the oil and gas industry is a drill collar in the mining industry. Basic things like units of measure, right? What you call the vertical elevation datum, right? So differences in language that you need to have a large and robust enough training set to have multiple examples so that you can point that machine learning algorithm, right? And once you start doing that, then you can use tools like Elasticsearch to say, I know I called it one thing over here and something else over here, but it's the same kind of data, and tell me something about, what the relationships are between those values across a large basin, right? So those are the places where machine learning is really pointing us to new ways and new ideas about how to ask questions of that data set.
It's so interesting because it feeds into yet another sort of a conversation we've had in this conference so far about large language models or AI being a store of corporate knowledge, that being one of the key issues that we have, bodies of knowledge, all that kind of stuff. And it strikes me that it could actually do that, right? And it could bring all those things together, and it could say, because it could know much more than one human could know, that drill collar is that well header, that is something else, and so on and so forth. And it may even draw correlations and patterns that we can't see, because who has all that experience? I mean, in one area. Fantastic, Jess. Thank you so much. Obviously, if anyone's got any more questions, I'm sure that we can chat about it in the networking session. But I think we'll say thank you for your presentation, and we'll move on to our next presenter.
Thank you.
If that's okay. Thank you, Jess.